Solutions for page 8 of quadratics. Number 5, another matching game. Match each quadratic function with its corresponding graph. Okay, so remember that depending on the format of the equation, it's easier to find certain characteristics than others. Okay, so most of the ones here look like they're in vertex form. So like this one, 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 right? These all look like they're in vertex form. These two are actually also in vertex form. It's just that since one of the coordinates, or both of the coordinates, are 0, it looks kind of funny. Okay? So what we're going to do first is we're going to identify the coordinates of the vertex coordinates for each one of these. Okay? So like, for example, this one here, the vertex coordinates are going to be -1, 3. How did I know that? Because this is x minus a -1, because the standard form is x minus h, and this is the k, which is 3. Okay? Let's do the next one. So this one would be 1, +1, 1, because this is a -1, and the h is just 1, right? Because it's minus h, so -1, h would be 1. This one here, the vertex and the x and y coordinates are both 0, 0, 0, right? Because basically this is the same thing as -x minus 0 squared plus 0. All right, moving over here. This one has -3 and 2, so h would be 3 and k would be 2. Remember that it's minus h, so -3, h would be 3. The reason why I'm writing these here is because I want to indicate that they're a vertex. Here we have +2, -2, +2, -2. Okay, and this one we have +1, +1. Okay, the tricky part is definitely the part where it says x minus 1. You might forget that it's x minus h, so it's +1 and not -1. This one here, the k is 2, the h, which looks like it's not there, is actually 0. So it's 0, 2. And here it'll be -3, -3. And here it'll be -2, -1, right? Because if it's +2, that means it's minus a -2, so the h value is going to be -2. Okay? So we found a bunch of vertex coordinates here, and now we're going to try to match these up. Okay. So like, for example, A. Capital A has the vertex at 3, 2, right? So if it's 3, 2, that means it's either going to be this one, and that's the only possibility, right? So this is going to be small b, this is going to be big A. Okay, so we've already found a match. This one here, B, the vertex is going to be at 1, 1. So let's see, 1, 1, capital B, or is it this one? Which one is it? Let's see. Well, both of them are pointing down, right? So, or opening down. So that doesn't help either. Now, one of them has an a factor of 1/2. The other has an a factor of 1. So one of them has a parabola that vertically goes down at a rate of 0, 1, 4, 9, right? And this 1/2 one is going to go at a slower rate. It's going to be, instead of 1, 4, 9, it's going to be like 1/2, 2, and 4.5. So let's check out this one here. What rate does this one go down? It goes down at 1. Oops. And the next one is 4. So it looks like it's going down at a rate of 149, which means B is going to be this one. So this will be small d. And I'm going to erase the d here because that one was wrong. Okay. Now what about this one? This one has a vertex at negative 1.5 comma negative 3. Is that right? Oh no, I'm sorry. It's negative 3 because this is negative 6, right? Just because there's only 2 marks here doesn't mean anything. It's actually, this is going to be negative 2 and this is going to be negative 4 because there's only 3 marks between 0 and negative 6. So it's negative 3 comma negative 3. Let's see, do we have any that, yeah, we do. We have this one here, F. So this is going to be big C, and this is going to be small f. Okay, so we're done with 3. Let's look at D. This one has a vertex at the origin, so it could be G, or it could be, it has to be G, right? That's the only one that has a vertex at the origin. So this one is G, and this one's capital D. What about this one? This one is the vertex is at 0, 2. So that would be C, right? C is the only one that has a vertex at 0, 2. So we're going to put small c there. This capital F1, the vertex is at 1, 1. So 1, 1, that would be either H or D, and small d has already been chosen, so it must be H. Okay, so let's see, this is going to be H, and this is going to be capital F. And how can we confirm that it's correct? Well, let's take one of the points, besides the vertex. We can't use the vertex, but let's try to take one of the other points and figure out if this point is in the satisfies the equation. So let's take this point here. It's the point negative 1, negative 1. If we put negative 1, negative 1 in this equation, is it going to work out? So negative 1 for x, it's going to be negative 1 minus 1 is negative 2. Negative 2 squared gives us 4. 4 times negative half gives us negative 2. Plus 1 is negative 1. So yeah, it worked out. So when x is negative 1, y is negative 1. So that was okay. So we passed our test, and so this is indeed H. Okay. Let's see, G. Here we have negative 1, 3 for G. So is there any vertex with negative 1, 3? Yes, A. So this one, and I think that's the only one, right? So it's got to be that one. So this is going to be small a. H, capital H. So this vertex is at negative 2, negative 1. So let's see, which vertexes are at negative 2, negative 1? Only this one at I. So this one is going to be capital H, and this one's going to be small I. And so the last one, there's only one left, right? Which one's left? E, small e. So this is going to be capital I and small e, and this is going to be capital I, small e. Let's just make sure it works. So this one has a vertex at 2, negative 2, and yeah, that one is also 2, negative 2. So we're done with this first part here. Here it's asking to find us the x-intercept for each of these quadratics. And there's a few ways to do that. One is factoring. If we find the factors, or the zeros inside that satisfy the factors, then that will tell us the x-intercepts. Another way is with the calculator. And another way is with quadratic formula. Okay? So let's show all these methods here. And when factoring is more appropriate, we'll use factoring. Okay. Now this one here, look at y equals x squared minus 9. This is a very famous factoring problem that also appears on the SAT. So if you have x squared minus a number, then this is going to factor into x minus a times x plus a. And this is just, you have to memorize this. It's going to help you on the SAT, among other things. So, and if you want to prove to yourself that it's right, do FOIL. X squared, the first terms, minus 3 times plus 3 is going to be negative 9, right? And the cool thing about this one is, when I do the inside term and the outside term, I get negative 3x and positive 3x, negative 3x and positive 3x cancel out. So then I just end up with x squared minus 9. So I just showed that if you have x plus a number and then x minus a number, if you multiply those together, you have the outside and the inside terms of FOIL cancel out, and you just end up with the first term and the last term. Okay? So the x-intercepts in this case are going to be negative 3 and positive 3. Okay? Let's move on to C. Y equals x squared plus 7x plus 10. Okay, so this is a factoring problem. Okay, it's not a hard factoring problem, so let's go ahead and do it. Okay, so the possible factors of 10 are 1 comma 10 and 2 comma 5. And if you look at these, which of these might add up or subtract to be 7? Looks like 2 comma 5, right? 2 plus 5 is 7, right? So we're going to factor this, and we're going to put x plus 2, x plus 5, right? And both of them are going to be plus because that's the way it works out, right? And so the zeros here are going to be negative 2 and negative 5. And so those are also the x-intercepts, okay? All right, let's move on to E. 4x minus x squared. You're looking at this, and you're like, this is a weird quadratic equation that only has 2 terms. Where's the constant term? Well, that actually makes it easier for us. If we factor this one, we're going to get 4, or we're going to get x, and then we'll factor out the x, and we'll end up with x times 4 minus x. Do you see how factoring out the x gives us that? So the zeros in this case, like let's say, oh, when is this equal to 0? Because when this is equal to 0, that's when the x-intercepts occur. So in this case, it's going to be x equals 0 or x equals 4, right? So these are the two x-intercepts. Okay? That wasn't too bad, was it? All right, now we're going to move down to the bottom, and these are slightly more difficult factoring problems. So I'm going to go ahead and show you how to do this one on the calculator, okay? So here we can easily identify that A is negative 2, B is negative 4, and C is negative 2. Make sure you consider the negatives as part of the answer. And so I'm going to go to PolySMLT, and I'm going to put in those numbers. So I'm going to put poly root finder, because that's where we find the roots, and we're going to put second order because it is a square order polynomial or quadratic. So we're going to put negative 2 in for A, or A2 actually, put negative 4 in for B, which is actually A1, and for A0 we're going to put negative 2. And then we're going to solve. And we get that both of the x-intercepts are negative 1. So the x-intercept is equal to negative 1. Okay? Let's do I now. We haven't done one with quadratic formula on this page, so let's do this with quadratic formula. It may not be apparent, but A is equal to 1 because there's nothing there, right? A is not 0, A is 1. B is going to be negative 4, and C is going to be positive 1. So let's plug those values into the quadratic formula. So we're going to have negative minus negative 4 plus or minus b squared, which is negative 4 quantity squared. Negative 4 quantity squared is going to be 16. Minus 4 times a, which is 1, times c, which is 1. And then all divided by 2a, which is just 2. So we have 4 divided by 2 plus or minus square root of 12 divided by 2. Square root of 12 is actually equal to the square root of 3 times 2 times 2. Okay, which is equal to 3 times the square root of 2 times 2. The square root of 3 times square root of 2 times 2, which is equal to the square root of 3 times 2. Okay, so you could rewrite square root of 12 as 3 square root of 2, and then when you divide 3 square root of 2 by 2, you end up with square root of 3. So this is also another way to write it. Okay, and 4 divided by 2, of course, is 2. Alright, so that's the answer for that one. And finally, we're going to have x squared minus 6x minus 2. Okay, on this case, let's solve this by completing the square. Okay, and completing the square, first thing you're going to do is you're going to rewrite this exactly the same as the way you did it, but you're going to leave a space here, after the minus 6x, and then you're going to put minus 2 kind of at the end. If you remember, the next step to completing the square is to try to figure out a magic number to put here where you could change x squared minus 6x plus something into a perfect square. Okay? So the perfect square in this case would be found by taking negative 6 divided by 2, get negative 3, and you square it, and you get negative 3 times negative 3, which is positive 9. So we're going to put positive 9 here because that's exactly what we need, and you'll see why. Now we can't just add 9 to this thing and not change everything. So what we do is we add 9 and then we immediately subtract 9. If we add 9 and immediately subtract 9, we're not changing anything, right? It's kind of a little trick we're doing here. So now what we're going to do is we're going to do a grouping. We're going to group these together, okay? And then the negative 9 and negative 2 we're going to group together. So now we're going to take x squared minus 6x plus 9, we're going to factor it, we're going to get x minus 3 squared, and then we're going to group negative 9 and negative 2 together, we're going to get negative 11. Okay? So now we have this in vertex form, right? We want to know when the where the x-intercepts are. So we're going to set it equal to 0, because that's where the x-intercepts are. We're going to add 11 to both sides. We're going to get x minus 3 squared equals 11. And then we're going to take the square root of both sides. We're going to get x minus 3 equals the square root of 11, plus or minus, right? And then finally, the last step, we're going to add 3 to both sides. So we find out that the x-intercepts are 3 plus or minus the square root of 11. Okay? And actually, that's the exact same answer you would get if you would just do the quadratic formula. Actually, completing the square always is going to look like the process of doing quadratic formula, because completing the square is the process that was used to find the quadratic formula. So that's why. But like, if you don't like this method, which I can totally understand why, because I think it's the absolutely most complicated, ugly method, you can use any of the other methods, except for a lot of times on the test, you may not use the calculator method.